Assalamualaikum warahmatullahi wabarakatuh. My name is Nurdiyana Binti Mohamad from 4BMMD, Section 2. Okay, today I will present about my final project, design and develop of sit-to-stand lifting mechanism for pediatric rehabilitation assistive device. Okay, first, I will explain what is cerebral palsy children. Cerebral palsy or CP children is a new neurodevelopment disorder caused by brain injury. So currently, there is no cure for the CP. So despite of this fact, there is no cure for CP. There is numerous invention that can help the patient live most functionally and enjoyable life possible. Okay, for the problem statement, the most accessible device in the market employs a lifting mechanism that are not affordable for Malaysian user. Thus, the project aim to develop the mechanical concept that lifting seat-to-stand features that could be applied in various assistive device. The main problem that cerebral palsy children face is where they have a hard time to stand. From the sitting position. This is because most of the cerebral palsy children have socialisis problem, so it makes them hard to stand by themselves. The assistive device that has sit-to-stand function is needed to help the physiotherapist reduce the burden of handling the CP children. Okay, this is the study research objective. The first objective is to design a new seat-to-stand mechanism concept that could achieve affordable requirement. Second, to develop and build working prototype of the new seat-to-stand mechanism. And third, to test out the prototype seat-to-stand movement and ability to lift up the subject with weight of at most 25 kg. Next, the methodology. Okay, next, the project and development procedure flowchart. Okay, this is the flow for this design study. So first, we are taking data from the stakeholder, which is a patient, CP children, parents, and therapists. We also done a literature review. We are searching the characteristic of the patient, the anthropometric study, design research, and then in another some research in reference for the study. And then from that, we analyze the posture and the anthropometric measurement of the cerebral palsy children. And then from the parents and the therapists, we are finding the method used from sit to stand from the patient for the patient. Okay, for the literature review, we are searching for the type of patient the patient needs, ergonomic research, operation analysis, and mechanism analysis. Okay, from all the data, we analyze the problem and the needs, and then we came up with the function analysis and the need. With all the data we are gathered, we built the design. We came out the design requirement and the objective. From the design requirement and the objective, we do design concept 1, 2, and 3. And then after that, the concept selection, design weight, and rating evaluation to find the final design concept. And after that, we develop the final design concept, and then we are making a working prototype, and finally we test the final prototype. Then next, this is the design flowchart. Seat to stand lifting mechanism for the pediatric rehabilitation assistive device. So the user basically is the children with cerebral palsy, and the design requirement is seat to stand lifting mechanism, reduce load required to lift the patient, and then able to lift seated patient up to upright. Okay. So the prototype design features and requirement. For the body, it needs seat, backrest, headrest, and footrest. So this is the basic, and of course the main point is the mechanism used for seat to stand. Next, I will explain the conceptual design. So there is 3 conceptual design. Design concept first, using 2 gas pump and left and right guide to make sure the backrest standing vertically. It using handle to lift the patient. Second, for the second concept, it's using also two gas pump, and it don't have any clear system to make the backrest vertical. So, and then the third one is, for the second, we are using step on the pedal to lift the subject. And then for the last one is design concept 3. It's using 4 pump, and then it's also have a back guide to make the backrest always in a vertical position. And lastly, it also using a handle to lift the patient. Okay, this is the weight rating evaluation. Okay, from the design concept, we evaluate every criteria that could be evaluated, such as lightweight, comfortability, easy to operate, durability, material, mobility, mechanism, function, and cost. So from this evaluate, we we got that the concept 3 get a higher score. So we using a concept 3 for the next design development. So this is the final design selected in 3D form, isometric view, and the back view from the design concept 3. Okay, after that, we are develop the design more. So the original design here at the left, and then the development process were made. Then this is the new design. So the design development process was made to simplify the final prototype design and easier the final work prototype fabrication process. So the different we can see here, for the original design there is a lifting handle here, but there is no lifting handle here. Next, result and this. So this is the final design rendering after the design development process, standing, sitting, and this is the mechanism of fly. So this is the detail drawing. When it's in a sitting position, the height, the maximum height of the prototype is 1060 mm, which is 101 meter. Centimeter. And then when it's standing, it almost 120 millimeter. Okay, next, the fabrication process. It involves a cutting process, divide and level process, combine the pipe, so make a small pipe, and then after that, the small pipe we assemble the pipe to form the working prototype, and then we done the surface finish. After that, we apply the mechanism, which is the gas pump, on the prototype. So make it perfect. And the next, okay, this is the final work prototype, the photo. Okay, this is the working prototype fabrication cost. It only costs 176 ringgit for the whole process, for the whole product, because we are using a mild steel, which is the cheapest steel, and then also the gas spring. The gas spring also is very cheap. It's only cost 4 ringgit and 55 cent for each unit. Okay, next, this is the working prototype testing. We test it in two conditions, which is with load and without load. So this is a standing, sit to stand position, and then stand to sit position. So this is the working prototype testing with load. We are using 23.6 kg of subject, which is the nearest weight to a 25 kg where we are already mentioned in the objective. So this is the standing position and the sitting position for the subject. Okay, same. This is the pace of the sitting to standing and then standing to sitting position. So to make it clear, So I ready the video for the testing without load. So this is how the prototype working without load. So from the standing position, come back to a sitting position. This is the testing with load. There is a bit problem for the sitting transformation. Okay. Okay, next the discussion. In final design concept, there is three main subject highlights such as back seat, guide, lifting handle, and gas pump. But after the design development process, the handle are removed because the handle will interfere the back seat guide function. The change of the design are shown as figure below. So this is what I already shown before this. So they're different, and then the reason why the handle were removed. And then the test result obtained is measured by the smoothness of the mechanism lifting load from sitting to standing position and smoothness of the mechanism work from the standing to sitting position. From the observation, the movement of the prototype change from the sitting to standing position is quite smooth when the test run without load, and it can lift the prototype without any issue. So the problem occur when the test run from the standing position to a sitting position. The force needed to make the position change a bit high, but it not impossible. And then the result obtained from the test run with load also has a different finding. From the observation, the lifting process are smooth, the mechanism working properly by reducing the force needed in the lifting process. So I can lift the subject easily, while there is some issue occur when the position change from the standing to sitting position. The gas spring cannot hold the load when it reaches 45 degrees from the standing position to sitting position. The pace of the movement change from slow to drop shockingly. So as you see at the figure, at the A region, the smoothness is quite okay, but when it come to B, it shockingly sit. So there is the problem there. So for the conclusion, according to the study that have been conducted, the mechanism chosen is able to achieve the objective of the research, which is the main objective is to design a new seat-to-stand mechanism concept that could achieve the affordable requirement to test out the prototype seat-to-stand movement and ability to lift up weak subject. Basically, the gas spring is good mechanism because the study proved that the gas spring is able to lift the weight smoothly, and it also cheap and affordable. There is only some problem that occur while the tests were run. The problem seems can be settled by improve the design or by editing the gas spring capacity. The work prototype was also successfully built and tested according to the study objective. Finally, the project has been successfully verified and full the requirement need to fulfill. Recommendation. In future improvement, seat to stand lifting mechanism could be improved as follows. First, change the gas load capacity by using a bigger capacity load. For example, using the gas capacity 15 kg in each left and right side, so that it can lift more than 25 kg easily, smoothing the seating process while load apply. And then add some mechanism that allow the seating process working smoothly. And other than that, the prototype frame also can be improved by adding additional body support such as trunk support or chest support to hold the subject firm while the test running. And lastly, build the adjustable side prototype. Okay, that's all from me. Thank you.